This video will cover when to use a part-part or a part-whole ratio. Please be prepared to take notes in your interactive notebook, and you can pause the video whenever you need to catch up. A part-part ratio compares one part to another part, like speeders to non-speeders, and cannot use fractions or percents. A part-whole ratio compares a part to the whole, like speeders to the total drivers, of which speeders is included in that number. Because of this, you may use fractions and percents. Let's look at an example. I have 3 boys to 4 girls, which is an example of a part-to-part comparison because I'm comparing 3 boys to 4 girls. If I wanted to switch that to a part-whole comparison, I can say 3 boys to 7 students because 3 plus 4 is 7, or I can say 4 girls to 7 students. I think this is a good time to stop and look at the fraction 2% or fraction percent issue. If I have written the part-to-part comparison as a fraction, it would have said 3 out of 4, which doesn't make much sense because this is telling me that out of 4 girls, 3 of my girls are boys, which we know does not make sense. So since it doesn't make sense, we cannot write it as a percent, because written as a percent, that is telling me that 75% of my girls are boys, which clearly the numbers does not support. Because if I have more girls than I have boys, then I can't have 75%. So this is why it doesn't make sense and why you cannot use a fraction or a percent when looking at a part-to-part ratio. However, because we switched this over to part-to-whole ratios, I can and am allowed to now do fractions or percents. I can say that I have 3 boys out of 7, so that becomes 3 over 7 or 3 out of 7. Now, if this was a benchmark fraction, I will easily know what the answer was. But since this isn't a benchmark fraction, I know that when I take my numerator and divide it by my denominator, I'll get the corresponding decimal, which becomes 0.4285 when plugged into my calculator. Because I'm looking for the percent out of 100, I only need to look at the first 2 spaces after the decimal. But this 8 tells me I need to round that up. So that becomes 43% of the total students are boys. Let's try a real life application. There are 2 girls for every 3 students in the class. If there are 36 students, how many of them are girls? First, let's look at what the question is asking us. I know we're talking about girls. I know we're talking about students in the class. At no given point in time are boys mentioned. So I know that I'm only looking for and dealing with girls to the total amount of students. This ratio was already written as a part-to-whole because you're comparing the number of girls to the number of students in the class. So I'm going to just do a straightforward ratio table, comparing girls to students. The first ratio I was given said that there were 2 girls for every 3 students. And my goal is to figure out how many girls there are for 36 students. So I'm going to skip some spots just in case you need to add some additional steps into the ratio table. Now, if you're comfortable with your threes timetables and you know how to go from 3 to 36, then you may not need the additional step. However, all problems aren't going to be as pretty and as neat, so sometimes you just want to give yourself the extra space just in case. In this example, I'm going to go from 3 to 6 because I know 3 doubled is 6. So if I double my 3, then I'm also going to double my number of girls. So that will make it for every 6 students, 4 of the 6 will be girls. Now to go from 6 to 36, I know my times tables and I know that I'm multiplying by 6. So now I can expect for every 36 students, 24 of them to be girls. Now we solved this using I know, the dreaded ratio table. So let's look at a different strategy for those of you guys that are still uncomfortable using a ratio table. Let's actually use the symbol for a ratio. And remember, it's always important to make sure we're still using our labels. So in this case, we're still comparing girls, colon, to students. And I know that I have 2 girls for every 3 students. And I must figure out again how many girls I would have for 36 students. I know to go from 3 to 36, I am multiplying 3 by 12. So I must also multiply 2 by 12 and still will get my 24 to 36 for girls to students ratio. Let's look at one last strategy, the fraction bar. Now I know because there's 3 students that I can split my fraction bar into 3 pieces. And since 2 of those 3 pieces are girls, I can label a girl, girl, and of course the remainder has to be a boy. Now if I have 36 students total, I must split those 36 students evenly amongst the 3 pieces. If I'm not as comfortable with knowing that 3 times 12 is 36, then I could just simply start with 6. So I could put 6 girls, 6 boys for 18 students, and another round of 6, 6, and 6 for a total of 36. Which means in each section I have 12 girls and I also have 12 boys. But I'm only interested in looking at the 2 sections with the girls. So I have a total of 24 students because 12 plus 12 is 24. Now, those are 3 different strategies to show you and get the same answer. It doesn't matter which strategy you start with. If you're more comfortable starting with the fraction bar, then start with the fraction bar. But eventually, challenge yourself to work your way to the ratio table. As long as you show your work and you're checking your answers to make sure your answers are valid, I'm okay with whatever strategies you start with, but please again make sure you are striving to head towards the fraction bar. On the next slide, you will have 3 problems that I need you to copy down into your notebook, skip a couple of lines in between copying each problem, and try the problems out. In about 5 to 10 minutes, we will go over the 3 problems as a group. Problem number 2. The ratio of students with short hair to total students is 4 to 5. If there are 36 students, how many of them will have short hair? Problem number 3. The ratio of long hair to short hair in the class is 4 to 5. If there are 36 students, how many of them have short hair? Once you've written these two problems down in your book, again, remember to skip some space so that you may work each problem out. Stop the video and go ahead and solve the problems in your notebook and wait for further instruction. If you are viewing this video at home, continue on to the next slide so you can see how the problems are solved. Again, remember to pause the video before moving on so that you may work out the problems for yourself to see the difference between your strategy and the strategy used. If you have any questions at that point, please feel free to contact me or check in with a peer to clarify any misunderstandings. The problem tells me my first ratio is 4 to 5, and that I have a total of 36 students. In this case, again, I'm going to just simply do a ratio table where I have short hair to number of students. My first ratio was for 4 students had short hair out of every 5 students. I need to again get to 36. Well, to go from 5 to 36, I'm going to have to break it down into 2 pieces and build it back up. So I think I want to start with 1. I know that 5 divided by 5 is 1. So 4 divided by 5 is 0.8. I can go from 5 to 35 by simply multiplying by 7. So again, 4 times 7 gives me 28. To get to 36, I just simply add 35 and 1. So to get to my short hair students, when I have 36 students, I add the corresponding columns, which will make that 28.8, or because I can't have 0.8 of a students, I should expect that 29 of my 36 students will have short hair. Problem number 3. The ratio of long hair to short hair in the class is 4 to 5. If there are 36 students, how many of them have short hair? This problem gets a little bit more complicated for 2 reasons. One, the initial ratio or information that we're given is long hair to short hair, which makes that a part-to-part comparison. However, our question is asking us, out of 36 students, how many of them have short hair, which will be a part to whole ratio. So we're going to have to do a couple of things in this problem. The first thing that we need to make sure of is when we're writing a ratio, whether it's in a ratio table or whenever we're setting a problem up to solve, is that we make sure that we're paying attention to the order in which the information is presented. In this case, the information is presented from long hair to short hair. So our ratio table must start with long to short, and we know that that's where the 4 to 5 comes from. The 4 represents the long hair student, the 5 represents the amount of the short hair student. So for every 4 long hair students in a class, you will see 5 short hair students. Now it's time to tackle the second problem. How do we go from a part-to-part comparison to a part-to-whole comparison on this ratio table? We're kind of going to create a triple ratio table, where this will be the total of students. So let's start filling this table in. I know if I have 4 students with 4 students with long hair and 5 students with short hair, that gives me a total of 9 students. The problem is asking me to figure out how many short hair students there are out of 36. And again, I'm going to skip an extra space just in case you're not as comfortable with your 9 times table and you have to take an additional step in between 9 and 36. In this case, I know that 9 times 4 is 36. So I can say 4 times 4 is 16. And even though I'm not going to draw an arrow in the middle, I have the 5 times 4, which will make that 20. So if my original question said out of 36 students, how many of them have short hair? 20 out of the entire 36 would have short hair. This triple ratio table isn't as common as some of the ones that you're used to doing. And if you're still struggling with doing a ratio table, then this one will be a challenge for you as well. However, it presents a lot of important information that could possibly help you in future problems related to the same question. I now can see that, excuse me, that shouldn't be a 4, that should be a 16. That 16 out of my 36 students will have long hair. 20 out of my 36 students will have short hair. And if I'm making a part to part of the whole entire class, I now see that it's 16 to 20, whereas in the initial ratio given, it was 4 to 5. Again, all sorts of information can come out of this triple ratio table. You just have to make sure you're paying attention to the details in the question and actually getting to what the question is asking you to solve. This is also a good point to note. The more information that you present in showing your work, the more follow-up questions you can have when you're asked to provide another example. This concludes this tutorial on part-to-part ratios and part-to-whole ratios. I cannot thank Mrs. Green enough for her valuable video in which I just simply adapted for our class needs. Thank you, Mrs. Green.